Okay, guys, this is for the grade level physics test week 3. We're going to be going through this in class on Tuesday, but right now I need you to look at this. If you're not going to be here on Tuesday, or you weren't here on Tuesday, or you just want to go over it Tuesday night before the test on Wednesday. So, first of all, vector quantities have, remember our little friend in Despicable Me, they have both direction and magnitude. Scalar quantities have magnitude only. So, some examples of vector quantities are velocity, acceleration, displacement, not distance. Okay, scalar would be speed or distance. Because acceleration is a vector quantity, when you have an object going around at 10 meters per second going around a corner, even though the magnitude 10 meters per second never changes, the direction is changing. Therefore, accelerating around a corner or going at the same velocity around a corner is still considered acceleration because you are changing direction. The answer to this question is yes. Notice down on the bottom this directly relates to your student data notebook. If you understand what we just did on this slide, you can check this one off on your student data sheet. Okay, so assuming that you traveled in one complete circle, starting and finishing at point A. So let's put point A right here. At a constant 15 kilometers per hour, going around in a circle at 15 kilometers per hour. Which of the following changed? Your displacement, your speed, your velocity, or none of these? Okay, you are comparing and contrasting here again your direction and magnitude. Well, if you go all the way around to A, which is what it says, assume that you complete the circle, your displacement did not change because you started and ended at the same spot X. So there is no change in displacement. Your speed did not change because it was a constant 15 kilometers per hour. So this was no change. Your velocity, however, did change because you changed direction, and velocity is a vector. Next, we did this in class on Monday. I believe everybody was in class on Monday, but just to remember, when we are talking about the average velocity between 4 and 5 seconds, that's here and here, we're going to subtract 20 minus 15 meters divided by 5 minus 4. So I took this, the last number, subtract the first number. The last number, subtract the first number. And therefore, the average velocity here will be 5 divided by 1, which is just 5 meters per second. And you can check this one off on your student data sheet. Calculate the velocity between 3 and 9 seconds. So the first thing when we're dealing with graph, remember, is what is on the y-axis. Y is equal to displacement. So on a displacement graph, they want to know what is the velocity between 3 and 9 seconds. Remember our DIVA acronym. If I'm at displacement and I want to go to velocity, I need to take the slope. If I'm on a velocity graph and I want to go to acceleration, I need to take the slope. So therefore, this tells us I'm on a velocity graph and or I'm on a displacement graph, excuse me, and I want velocity. I need to take the slope between 3 and 9 seconds. So my slope is equal to my change in displacement over my change in time. My change in displacement is 15. That's right here. Okay, so that's 15 minus 10. And my change in x is 9 minus 3. So this is equal to 5/6. And I would expect you to actually divide that out in your calculator and get you a decimal. Okay. So if you understand this, you can check off, given a graph of position versus time, which is what you were given, you determine the average velocity. Next, this is average speed. Remember, average speed is different from average velocity, because if you want average speed, it's going to be equal to your total distance divided by your total time. So in order to get this, I have to add up all of the distances. I've got 5 miles to go to McDonald's. He stands there, wait for his order, 10 minutes, and then he goes 5 miles back to school. Okay? That's equal to 10 miles. The time is 10 minutes to get to McDonald's, 10 minutes to wait for his order, and another 10 minutes to get back to school. So that is 30 minutes altogether. So therefore, the answer to this question is the average speed is equal to 0.33 miles per minute. Okay, this graph. We had this in a couple different warm-ups. You need to be able to know what all of these cars are actually doing. So 4 cars are traveling on FM 1960 when the signal starts to turn from green to yellow. From the graph below, which one of the cars can we assume followed the traffic laws correctly? So if we're going from green to yellow, the cars should slow down. So the question is really asking you, which one of these cars is slowing down? Well, car A, we remember the first thing we do is we look at what's on the y-axis, it's speed. And notice when we start, car A is going 60 meters per second, but as we go down, the speed is decreasing until it comes all the way down to 20 meters per second. So the car that is actually slowing down would be car A. Let's take a look at the other cars. Car B starts at 45 meters per second and ends at 45 meters per second. So it didn't slow up or speed up. It did neither. It kept going at the same rate of speed. Car C actually is accelerating. Car C is accelerating at a constant acceleration. So for every second that car C is moving, it increases its velocity the same amount. Car D is also accelerating, although it's not accelerating constantly or uniformly. In this part, it is accelerating much faster than when it gets up here, and this is constant acceleration here. Okay, so if you can analyze and compare the motion of these cars and know what they're doing, then you can check off this on your student data sheet. In this one, we need to know, in the following graph, where is velocity and acceleration increasing? Where is it decreasing? Is it staying the same? Also indicate if there is a change in direction. So the first thing, again, that we have to know, every single graph, what have I said? The first thing we need to know is what is on the y-axis. It's displacement. So let's take a look at velocity. Displacement on a displacement time graph, if we have a curve, we have acceleration. So at this point on AB, acceleration is increasing, which means that velocity is increasing. That's a little arrow pointing up is what I'm trying to draw. Let me draw that a little better. Arrow going up. Okay. Oh, I take that back. Acceleration is constant. Acceleration is constant here, but the velocity is increasing. In section B to C, there is no curve. It's just a straight line. So that means that acceleration is 0. Velocity is equal to a constant. And that is only because it's on displacement is on the y-axis. In C and D, it'll be the same. It'll be the same here. It'll be a different velocity now, but the velocity will be constant during this section. Acceleration will be 0. During this point, acceleration is equal to 0, and so is velocity is equal to 0. Now you notice, generally speaking, the slope turns around and goes the other way. So we, generally speaking, have a negative slope. If we have a negative slope, that means we change direction. So it's at this point right here that our object changed direction. And in this place, because we have another curve there, that means that we do have acceleration. This time it's deceleration. Okay, so acceleration is constant. Okay, and velocity here is decreasing. Here, acceleration or deceleration, if you will, it's negative acceleration. Negative acceleration, if it were to be any, is equal to 0. So I guess I can't say it's negative because it's 0. And the velocity here is decreasing. Okay? And we get down to the end here. Here we have now a constant acceleration. And our velocity is actually increasing a little right here. Okay. So this is determine direction and motion. So right here we determine direction and motion of the motion from a displacement time graph. You can check that off. Here we understood what the slope of the motion time graph was, and the y-intercept we didn't discuss. The y-intercept, remember, is where does this line cross the y-axis? It crossed it at 0. So therefore this object started at the 0 position. Okay. So we have a garbage truck going through the neighborhood. The graph begins as the truck leaves the house. Here we have a y-intercept. If we assume this is where the y is, all right, the graph begins as the truck leaves my house heading west. That means that it didn't start at wherever the 0 point is. It started someplace away from wherever the 0 point is, maybe back where the garbage company is. All right, so it says, in which direction is the truck traveling at 10 seconds? So here's 10 seconds. It started out west. This is, again, what is on the y. It's a displacement. So therefore, I still have at 10 seconds positive slope. This is still a positive slope, so that means at this point it is still heading west. At this point it stops, and now at 16 seconds the slope becomes negative again, or becomes negative, and therefore at this point it would be going east. Here, sorry, it's a PowerPoint. Here it stops. Here it continues east. Here it stops. Okay. Check off your student data sheet. Okay, you are going to be given a story and be able to have to interpret it just on a graph, just like the posters we made. Coach BB drove to the transportation department to pick up his bus. That would be this section right here. After waiting for his keys, and remember, look at your y, this is displacement, so this means he was stopped here waiting for the keys. He headed back to KF, where he had to wait for his team. So here he's headed back to KF. And at this point, he's waiting for his team. He stopped here. He then drove to the stadium. Okay, what you have to do is say which one of these choices actually is happening at W. Well, if this is a displacement time graph, this means at W, Coach BB is stopped again. So, choice A says he drove back to the bus lot. Well, no, if he drove back, that would not be stopped. He coached his team to victory.
Yeah, I've got a bunch of those already downloaded from the Silk website. You emailed to me.